Am I audible? Okay, yes. Okay. So let's discuss the contest Codeforces Round 21029. Okay. Let's see our first question. I have the solution with me, and if you want the solutions, you can check out the description below. So what our first question says that in this first question, yes, we have to count the ones, that at most one. So there are some of the doors. The zero indicates that the door is closed, door is open, and one indicates that the door is closed. So when we have the closed door, we will open the key. Okay, and the key, we have the key, but that key can open the door only for k, that this is the k which is given, k seconds only, and we have to cross that all the closed doors in that k seconds only. So it's not that much difficult. We have to now we have to that find out that how much is the first occurrence of a and last occurrence of a, 1. Okay, so first occurrence of closed door and last occurrence of closed door. So when we reach to the first closed door, we will use that key, and that key will open that all the closed doors, or all the closed and open doors, and that key will open all the closed doors for up to k seconds. And in that k seconds, if we able to pass that all the doors, or all the closed doors, initially closed doors. Okay, but if we are not able to get we are not able to get out of that all the closed doors, so it is not possible to get out of that. Okay, and then we have to print no for that. So it's code, let I show you the code. Okay, so we have taken the input here, k is the we have the key, and the key will last for this k seconds. Okay, so when we have to use the key, when we get the first closed door. Okay, so we have the array of the closed and open door. We have taken the left as a int max and int min. To get that, left will be storing the first closed door, and right will be storing here the last closed door. So that's why we have taken initialize it with int min, and yes, and we can initialize it with the -1 also, and with the this with n+1 also. So but we will have any of them, that if we didn't have get the any of the door is not closed. Okay, so we will print as a yes, because if any of the door is not closed yet, so we can already pass without using the key. And if any of the we will get any of the closed as a any of the door as a closed door, so we will update the left and right doors. Okay, left and right doors, that minimum of them and maximum of them. So maximum will return that that the rightmost door which is a closed door, and leftmost closed door, left will store the leftmost closed door. Okay, and if this that r minus of l means, in this case let's see this case, that this is the index 0 1 2 3, so 3 minus of 0 plus 1, because 1 2 3 4, in 4 seconds we have to pass this window. Okay, but we cannot able to pass this because we required the 4 seconds here, but we have only 3 seconds, so its output is no. So that's now our output, that r minus of l plus 1 should be less than or equal to that window. That window should be less than or equal to the k. That k is the maximum time at for which the all the closed doors will be open. and that's how we have to print the yes and no. Okay, so let's see the second question. What the second question do? Shrink. Okay, the shrink operation on an array A of size m is as follows, and shrink operation. Okay, so here what this question says, that we have the permutation. Okay, permutation of this size. Okay, we have to make the permutation of this size only. Okay, and what we have to do in that permutation, we have to get that permutation should satisfy this condition, that we have to choose any of the index, and any of the index, its left one. In that index, its left one, like this, here 6 we have chosen, and it is greater than the left one and right one. Okay, means right index. Okay, only one index. Okay, so it is greater than that, so our count will be plus plus, and we will delete this 6. Okay, so we have to delete this maximum like that. Okay, and after getting that maximum, okay, after getting that maximum all, when so how do we get the maximum? So we can store it like that. We are storing the greatest one. Firstly, we will storing the greatest one. Then we will sort the array first, and we will go in the decreasing order. Okay, decreasing order. But now, what will be the again easy way to do this, that we have to print all the even first, and after that we have to print all the odd numbers. Okay, so this 4 can be on here and 6 can be on here. So if because there are multiple answers can be possible, so we can print this also. Like if we talk about this answer. Okay, so there are 1 2 3 4 and 5. So when we talk about this, that's 6, up to the 6. Okay, 6. So when our solution returns all the first even numbers, then odd numbers in the reverse order. So it will return that all the even numbers as 2 4 and 6. After that we will return the 3 to 3, then 1. Okay, sorry, 5 3 and 1. Okay, so what it will do, that we are selecting the 6 and deleting it. After that we do not have the 6 here. After that we are selecting the 5 and deleting it. Our count will be 2. After this we are selecting the 4 and deleting it. Okay, after this we are selecting the 3 and deleting it, and that's how we can delete the 4 elements. Okay, 4 elements which are the greatest one. Okay, greatest 4 elements. Okay, so that's how our solution works. Now let's go to our C question. Okay, question number 6, C. Okay, so it's also what it says, that Yusuf. Okay, Yusuf, we have, okay, good, a cool partition because every element of the B where, okay, yes, so what it says, that here we have given the input arrays. Okay, the cool partition, we have given the definition of the cool partition. What will be the cool partition? That if we partition the 1 into one sub array, after that we are partitioning this, okay, this as a one sub array. So this sub array should contain all the elements before which is slide before that sub array. Okay, so here 1 2 is a subarray, and 1 2, and the b2 which is a subarray, it contains all the elements from b1. Okay, that should be satisfied by every subarray, and we have to make this most of the subarrays, that how much maximum number of subarrays we can make by using this condition. Okay, these are the cool partition. Okay, that how much cool partitions we can do. So when we talk about this, okay, this, let's take this question, this example as we okay, so initially I thought that that you have to create one of the index. So what we have thought, let I explain you with this my code. Okay, so we have to maintain the next occurrence of that element, because if the one, now till this we have partitioned one of the array, and but this element should be this 1 2 and 3. Here 2 and 3 are present after this, after this index. Here 2 and 3 are present, but 1 is not present. So that's why 1 should also be present there on the next occurrence. Okay, 1 should be also be present at the right hand side. So here it is not present, so that's why if we have taken all these elements, so we have to take all the elements. Okay, these two elements also, because we do not have the next occurrences of 1. Okay, next occurrence of 1 we do not have, so that's why we have to store at every index its next occurrence we have to store. Okay, so when we store the next occurrence of every of the element, like that, when 2 1, so we have stored the 3 occurrence of the 3 as a this. Okay, and minus of 2 here. Okay, means like 6. Okay, at the 6. Okay, and 1. Okay, 1 has the next occurrence as the this. Okay, let's start with the initial one as a 1 only, 1 index only. Okay, so we will take initially the 1, this left and right, our boundary will be only for we will take only one element. Okay, and after that we will increase that up to which that element, that now the next occurrence of 1 is here, so we have to increase our right boundary. Okay, our left boundary will what, next left boundary will be the r plus 1, because we are going up to this index, we are starting from that index and going up to that index only, that 0th index only. Now our next index, what will be next starting index, will be the r plus 1. Okay, this, because we are making this subarray and we are starting from next, we are starting our next subarray from this index r plus 1. Okay, and we can go up to the last or end. Okay, so we now we have to decide the r, our next r index. Okay, so up to which we have to go, so that will be decided using the next occurrences of the 1, or the maximum from next maximum from the next occurrences of the 1, next occurrences of that indexes of that subarray. Okay, now we will find out the maximum next occurrences from that all the indexes which we have traveled from L to R. Okay, now that L to R range or their next occurrences will decide our next left to next right limit. Okay, and if that next left to next right limit will exceed, that right is exceeded to the like -1, I guess. Okay, or next occurrence will be, okay, how to play the next occurrence. Okay, yes, because of the we have given there int max, so the when we do not have any of the occurrences to its right, so it will be default as a int max. So if we get any of the element which do not have the next occurrence, so it will be treated as a int max, and the next r will be as a int max. So it is not satisfying now the condition that it should be less than n. So that's why the loop breaks there when we get any of the element which has next, which doesn't have the next occurrence. So that's why our loop breaks, and we have printed the answer, that how much of the good subarrays, that cool partitions can be printed. So this is our C question. And retaliation. Okay, so this is one of the question which is not that much, is because C number of yes, many number of have individuals have done this question, and 10,000 nearly. Okay, so it's not that much hard, that binary search can be applied, but I have applied here the, okay, yes, here two approaches can be there. Binary search is also can be applied, but I have used about the linear that simultaneous equation method. So we can decrease the a of I by I, or decrease the a of I by n minus of I plus of 1. So now to solve this, when we have this, okay, so let's take this example, and here is the code. Okay, now, okay, this is the example. Now we can use here, we can decrease it by 1, decrease this by 2, decrease this by 3, decrease this by 4, and this by 5u. Again we have another option, that decrease it by 5u, decrease it by 4, it by 3, decrease it by 2, and decrease it by 1. So we have these two options. Okay, this two options we have, and this is the our main this solution. Okay, now we have to see that by using this two multiple times, okay, this two multiple times, we can use it either 0 or many times. We can use this also either 0 or one time, or either 0 or many times. Okay, so now we can able to analyze that, we can make here the simultaneous solution, because simultaneous equation, that now we are using the phi u. Okay, let's see this as x, and let's analyze, let's take as a y. Okay, so the 21 we can make it by using the 1x, 1 into x plus phi u into y. Okay, phi into y, which is equal to the 21, and just like that 2 into 2x into 4y is equal to 18. So this will be the simultaneous equations. Okay, so here is the 2x plus 4y is equal to 18. Okay, this is the simultaneous equation. We have to solve it, and we will get the values of x and y. So x value we will get, and y value we will get. Okay, by using which we will find out the x and y, and by using that we will apply the x and y value to this, and minus that x and y value, that x multiplied by 2, y multiplied by 4 from 18. And if we get minus, or if we get any of the number other than 0, so it will be not possible to make that make that as a good, like retention, means we cannot make it by using this as a 0. All numbers we cannot make 0. And we take the formula of x and y. Let's take the formula of x and y. So you can solve this equation and make the formula. It's not that much hard. You can try it once. And if you didn't get it, so please mention in the comments that you want that explanation, so I will share you the link of that how to solve this simultaneous equations. Okay, now this will solve the x and y value. We will get this x and y values. So sorry, I have been mistake. Okay, yes, so there's a x and y values are there. Now after getting that x and y values, we have to get the flag, that minimum and maximum, that we can make this also, or we can make this like if minimum or maximum, or if array of I is not equal to the 0, we can make it like that. If array of I is not equal to 0, so the flag is equal to false. Okay, now here we can take that flag. Okay, if flag is true, then only it will be true, or it will be false. Okay, now okay, so there can be conditions that this can be negative, but any of them cannot be negative. Like we cannot use the x like this, means this number of this numbers we cannot use negative times. So this will be the like bypassing the logic. Okay, so now so it's like if we are taking the x as a negative or y as a negative, so it's like just like that, we on in place of the decreasing it, so we are increasing them. So if we have both the options that we can increase or decrease, so if we have both the options that we can increase and decrease also, and decrease also, so we can use that x as a negative, but here we only have to increase this. Okay, sorry, decrease this. So that's why we only have to get the x as a positive and y as also positive, or it can be the 0. Okay, but it cannot be, any of them cannot be the 0. Okay, they cannot be the negative, sorry. Okay, and after that let's see that we have updated this some of the functionality. So let's see if it is work, and it obviously it will work, but let's see that it is working correctly or not. And let's wait for some time, and I guess this will work. Yes, this has worked. Okay, yes, let's refresh it. Okay, yes, accepted here. So that's it for today's video. So let's see you in the next Codeforces contest, virtual contest. So goodbye for today, and we will see you on the next video. Until then, revise all the codes and practice on Codeforces as you can, and give your 100%, because you have to do something, otherwise life will do something with you. Thank you.